Let's discuss terminal characteristic of compound motors. Remember, in DC machine, here was poles on the outer part, which is stator, and then yoke, and then here is rotor or armature, slotted construction. There are armature windings, and here is commutator. There are brushes touching to commutator. Those are armature terminals. Let's say A1 and A2. Here in compound machine, here are two different excitation winding. One is, let's say, shunt winding. Let me predict. Okay. Here's a winding having thinner diameter wire, lots of turns, and then they are connected series. This is shunt winding. Labels are F1 and F2. And there is one more winding, which is serial winding, having a thick wire and a small amount of turns. Let's do it. Here is a serial winding. Of course, it is not easy to show you. Serial 1 and serial 2, those are the terminals, and you remember that here is the connection diagram. Motor DC, that is the armature having A1 and A2 terminals, and here is shunt winding. Let's say that's it, F1 and F2. We generally connect first letter to the positive terminal, so I plan here is the positive, so I have connected F1 to positive. That is a thumb rule, not a strict rule. Here is another coil, which is series winding. Let me say S1 and S2. Here is positive terminal of the supply. I apply some VT here, positive and negative, and here are currents. I load. I field serial, armature. I field shunt, as you see. Now the problem or difference comes from here. Here's a magnetic pole. There is a magnetic field coming from, let's say, MMF or shunt field. Here's shunt field coming from this winding, and there is another field coming from serial winding. Houston, that is the decision point. Here's the serial field that would be accumulated, making higher summation. Total flux will be larger than shunt field. I mean, serial field supports the shunt field, and there is a larger cumulative value, cumulative compound. The other alternative is having a shunt field again, downward, that is phi shunt, and here would be a serial magnetic field which is opposing, causing a differential result. Such a connection called as differential compound, as you know from earlier. There are two possible options. In one option, serial winding supports shunt one, resulting cumulative compound. In the second option, serial winding would decrease the total flux, that is called as differential compound. So we discuss terminal characteristics, we discuss speed torque curves. As you understand, that is a mixture of shunt and serial motor. Remember, that was the serial one. We have already know serial motor terminal characteristic. Again, remember, that is the serial. Let's say that is the shunt. In such a case, possibly there are two different results. If there is an accumulation support from serial winding, that is result in larger field, cumulative result. If field increases, speed will decrease a little bit. While torque is increasing. If this result is differential, in such a case total flux will decrease and speed will increase. That is differential compound. The mixture of the result wouldn't be known. It depends the design, it depends the manufacturing of the machine. Here are some ampere turns, you know. Here are some MMF coming from shunt and serial one. So that would be positive or negative. That is the total MMF. Total MMF over reluctance will result in total pole flux. So here connection of winding is important. It would be cumulative and differential. We always discuss this one, whether it is supporting or distracting. That's it. Let's conclude. The result will be one of this: differential and cumulative compound. Perhaps you remember in the beginning we talk about short shunt and long shunt. It makes not much difference, but cumulative or differential connection makes dramatic change. Let's remember you. How can you manage differential and cumulative? Motor. Here is armature. Here is shunt coil. And here is serial coil. Let's assume that those are in the same direction, so that is cumulative compound. If you reverse this guy, let me say F1, F2, serial 1, serial 2, here are the positive terminal and negative terminal. If you reverse this guy, let me show you. Motor, A2, A1. Here's the shunt field coil having the same connection, but we reverse connection here. Here is S1, here is S2. The terminals in the serial coil is reversed, so making distraction, not addition. Here is VT, that is called as differential compound. The result is the mixture of both unique characteristics. Okay, ladies and gentlemen, as you see, differential compound motor has a better speed regulation, While you load motor, there is not too much speed change, as you see from the figure. Speed changes a little bit. We use differential compound motor to have a better speed regulation. We prefer differential compound motor in generator applications. If there is a differential compound, total flux will decrease with respect to load current. So short circuit, that is generator, short circuit current will be decreased. So we use such a differential compound connection for a better current regulation. Use for current regulation. For example, constant current sources in welding machines. Cumulative compound generator is used in voltage sources because when there is an increasing load current, it is equal to serial field current. If that field make a contribution to shunt field, total flux will increase. As a result of total flux increase, there is an EMF increase. If there is an EMF increase, there would be possibly constant output voltage. Remember approximately the generator equation. EMF is equal to current array plus voltage. So terminal voltage is equal to EMF minus current array. Ladies and gentlemen, if you increase load current, there's an increase in armature current. If there's an increase in load current, there's an increase in flux and EMF, and there's an increase in EMF. So output voltage will be kept constant. Such a cumulative compound generator yields us better voltage regulation. In motor mode, we only use differential motor, making better speed regulation. In generator mode, we prefer both one. In voltage sources, we prefer cumulative compound. In welding machines or current regulation, we prefer differential compound.